Hello, everyone. So this is example 1-2. It's about the continuity equation. An engineering company was assigned to estimate the unsteady flow discharge at a section upstream of a river. In order to estimate flow discharge, water level variation with time, dy dt, flow discharge, and surface width were measured in a control section. It was found that the water level increased at the rate of 0.2 meter per hour. Flow discharge and surface width were 20 cubic meter per second and 18 meter. Determine flow discharges at 1.5 kilometer and 2.5 kilometer upstream of the river section. So we have a river section. And this is the water surface. So in a control section, I call it section 1, we have the flow measurements, flow discharge. At this point, Q is equal to 20 cubic meter per second. And then the top surface, if I draw the cross section, then the top width was also 18 meter. And then we have a rate of change of depth as well. So if I call this y, then we can write the continuity equation in unsteady form. So we have di q di x plus t di y di t is equal to 0. Okay. So we have the range of rate of change of depth with time, and then we have the top surface, and then we have a change on discharge. So we have two different distances, and then it's a partial differential equation because we have two variables. We have distance and time. So if I replace the value, I can write here Q2 minus Q1 divided by delta x plus t is 18 and dy by dt is 0.2 meter per hour. So it's 0.2 meter per hour. And I need to multiply this to change it with hour to second. So 1 hour is equal to 3,600 seconds. Okay, so this way, hour and hour cancels out. So what I have here is I have meter and then second, okay? And then it's equal to 0. Okay, so a Q2 is given at the section that it's downstream. So here I have 20 cubic meter per second minus Q1 divided by delta x is 1.5 kilometer. I need to multiply that by 1,000 to convert it into meter, plus 18 times 0.2 divided by 3,600 is equal to 0. Okay, so if you rearrange this, then you will get Q at 1.5 kilometer is equal to 21.5 cubic meter per second. So you need to keep in mind that all the units should be in meter and second. So here I have 18 as a top surface as a unit of meter. Here I have meter, and then here I have second. And same thing, discharge is cubic meter per second. And then here is the rate of change of discharge over distance, and the distance is also in meter. So all the units match up. So for part B, we do the same thing. So the measured discharge at the downstream is 20 cubic meter per second minus Q2 here, or I can just call it Q1, divide by 2.5 times 1,000 plus 18 times 0.2 divided by 3,600 is equal to 0, and that gives me Q at 2.5 kilometer distance is equal to 22.5 cubic meter per second. Okay, so